Hi everyone, welcome back to the channel. If you have been tasked before with building an internal development platform or IDP on Kubernetes, you know how much of a complex and fragmented task that can be. Typically, platform engineering teams have to start from scratch. They will have to stitch together GitOps with CI/CD, with observability tools, and then put them together so that the developer can use them so they can build and deploy applications. But what ends up happening is that the platform teams will end up owning the glue code, as we call it. And that glue code grow more complex and harder to maintain and upgrade. What platform team wants is standardization and ease of use. And what developers want is simple interfaces, golden paths, and tools that can allow them to get their applications from development to production easier. What if I tell you you don't actually have to reinvent the wheel? This is OpenChoreo, an exciting new open source internal development platform, which is a CNCF sandbox. Originally developed by WSO, built on years of experience of building SaaS platforms for developers. It provides you with a complete multi-plane architecture, Backstage-based internal development platform, which is easy to use. Unlike other platforms, OpenChoreo doesn't try to hide Kubernetes behind the black box. Instead, it actually augments Kubernetes native APIs, providing you with a GitOps experience using Kubernetes as a system of record. Let's take a look at the developer portal of OpenChoreo. I have already deployed OpenChoreo on top of GKE standard. You will find the link in the description for the step-by-step guide for how actually I did the deployment. I can see here that I have a catalog, and my catalog is a reference of all the projects. OpenChoreo has a model where at the top of that hierarchy, there is something called a namespace. You can create as many namespaces as you want. Within each namespace, there is projects, and then within the projects, you have all your applications. And this is just a way for you to organize your resources. So you can create namespaces, which contains projects, and then each project can be owned by one or multiple teams. And inside the projects, you will have all the application components of that particular project. There is this awesome platform view, which actually gives you a really great way to visualize OpenChoreo entire system. I can see here that I have a default project, which is the one deployed by default when I set up OpenChoreo. I have the project I have deployed myself called Doclet. I'm gonna go into it in details later. Then there is a built-in default pipeline, which basically has three environments: a development, a production, and a staging environment. Everything here is customizable. You can create all the pipelines you want and all the environments you want. On the left side, my Doclet project has 5 components. They are split into 2 different categories. This is the resource model of OpenChoreo. There is what we call a component and a resource. Simply put, a resource is any piece of infrastructure your application need: databases, queue systems, etc. In this particular case, for the Doclet app, I have a NATS resource and I have a Postgres resource. And then I have 3 different components, which are my actual applications. So these are the stuff that you're actually going to build. I have a collaboration component, I have a document component, and then I have a front-end components. Typically, developers who are building and deploying applications on Kubernetes will have to craft YAML files or maybe use templating systems like Helm and Customize to try to make things easier. But OpenChoreo comes with a component model that allows you to actually declare all your components as high-level objects, and then OpenChoreo, we know how to roll them down inside each environment and then turn them into pods, stateful sets, etc. So in my particular project called the Doclet, I have 2 pieces of infrastructure, NATS and Postgres. If I look, for example, on Postgres and I go into the definition, I basically have defined this as a resource. And basically, it's inside my namespace, and it's just a database. And that's it. It's very simple. Then if I also look at the NATS, it's pretty much the same thing. It's just a very simple definition that says, okay, this is my resource, it's called NATS. These are based on templates which you can also define yourself. Now, my components, on the other hand, like for example, my front end, are actually my own applications. So in the definition, I have defined them as a component, and I basically have declared that there is a component called, in this case, collab component. So this will just declare the component itself. It's not going to deploy it. Then when I go into the deployment part, then I have to still set it up by providing it with either the code so that the built-in Argo can build the code and package the container, or in this case, I just built directly from an existing container, which is provided by Choreo. And then I have these rolling stages. So I have already rolled all my components into the development stage, and then I can also roll them forward into the staging and the production stage. Let me show you two cool things I really like about it. One of the things I did actually when I was setting up my Doclet Postgres, which is my database, is that in the deployment setup, it actually asked me, do I want to enable an admin panel, which I have done. So let me show you how that looks like. It's here, admin enable. I have actually turned it on. And what that did is that it automatically created an extra pod called the admin pod. So this is actually out of the box provided by OpenChoreo. It's just a web interface that allows you to administer my Postgres database. So now if I go actually to my component here, I click on it and I go into configuration, not configuration override, sorry. If I go into outputs, it of course created automatically the username, password, and it wired everything up. OpenChoreo uses OpenBow as its backend for storing the secrets, and then it used external secrets to sync them into Kubernetes secrets. It generated all the passwords and stored them automatically for me. I didn't have to do anything. Then I have this admin panel here, which if I go to it, I can log in to basically my Postgres database. And I can see here that I have a table called documents. This table is created automatically by the application when it starts. Then in my components interface, I have my front end. So in my front end, if I click on it and go to the deploy stage in development, OpenChoreo has a built-in gateway, which basically automatically registered a URL, including the HTTPS endpoint using Cert Manager for my front end, for my application. By default, everything is using sub-signed certificates, but you can, of course, use Cert Manager to define your own certificates. This is my application, and it's essentially a simple version of Google Docs. It allows you to create a document. Let's create one called test. And behind the scene, I can actually collaborate on this document as one user. And what I can do is I can take my phone, share the QR code of this particular document, then scan it through my phone, and then very quickly you should be able to see that there is another user coming there and making changes to the document, and then each has their own username. The way this works is that the document itself is stored, or the content of the document is stored inside of Postgres, and then it uses NATS as a way to create the events. So when one user is editing, it goes through NATS to write the changes and then reflect them on the front end. And this is actually what I can see here if I go to the cell diagram. In the cell diagram, because when I was declaring my components, I also declared the relationship between them. It created this boundary. This is the namespace where all these components are deployed. This little component here is my gateway, which points to the front end. And then the front end talks to the document, talks to the collab. They both talk to the NATS, and then the document component talks to the Docker database. So it gives you actually this great interface where you can see the relationships between the components and how they talk to each other. This other diagram shows you the much higher level relationship between the hierarchy of components inside OpenChoreo's storage itself. So here I can see that I am inside the default namespace. I have this project called Doclet, and then it has 3 components. And then for each component it gives you a relationship. Either it's a dependency or it's part of. But having this visual interface is great. Having something where I can actually query the entire system to look at what it's doing would be better. And this is where some of the built-in AI tools of OpenChoreo comes into the picture. So if, for example, I go back to the catalog and click on my Doclet application, or my Doclet project rather, go into the logs, for each of these logs, so these are the aggregated logs across all the components, but actually I have this little component here called the Portal Assistant, which is an AI-based investigation tool that I can use to talk to my components. I can, for example, say, is this component healthy? So I have talked earlier about the multi-control plane architecture of OpenChoreo. We're going to look into it in a second. But basically, this is actually, so what we see here is it says it's unhealthy because it's based on very recent logs. And these, I believe, are old logs. If I look, I was playing around, so I caused an incident. And in this case, it was saying, like, okay, this doesn't look very healthy. If I scroll a little bit further, I can say, is the collab component healthy? and I should be able to see that it is. So the way this portal assistant works is that it actually leverages OpenChoreo's built-in MCP servers. Each component in the control plane exposes an MCP server, the observability component, the control plane component, the workflow components, etc. And then I can use either the built-in portal assistant to talk to these components, query them, ask them questions, or I can actually use an external AI assistant like Claude Code or Anti-Gravity, and I can use it connected to the MCP server built inside OpenChoreo and use that to actually investigate what's going on inside my cluster or inside my applications. I'm gonna try one thing, and if it doesn't work, let's scrape it. Let's see something else. And this is just to show you the context awareness that OpenChoreo has when it comes into the MCP servers. So if I, for example, look at the document server, I can check, is this component running out of resources? Do I need to upgrade them? So as you can see here, I asked if my component is actually running out of resources. This is a very common thing in Kubernetes, which is you either undersize or oversize your pod, and then your applications end up running slower. In this case, I just asked, is this component running out of resources? And I got a straight answer. Before, you could see that it actually was querying, doing some queries. So this is using the MCP server to actually query what are the current resource utilization of this particular component, which is in this case is the document. Now that we have explored the interface, let's look at behind the scene what's going on. So if I actually query my cluster namespaces, I should be able to see that I have multiple ones, which are the OpenChoreo ones. So as I said earlier, OpenChoreo has 4 control planes. Each control plane is deployed inside its own individual namespace. This is called a single cluster deployment. I can also have a multi-cluster deployment. There is also a namespace called Tender. Tender is the identity provider built inside OpenChoreo, which provides the identity for the user. Tender is the identity provider built inside. There is also a namespace called Tender. Tender is the identity provider built inside OpenChoreo, which provides the identity for the users, etc. And then OpenBow is the secret backend of OpenChoreo, which allows us to actually store secrets. And then there is also external secrets, which will etc. And then OpenBow is the secret backend of OpenChoreo, which allows us to actually store secrets. And then there is also external secrets, which will be syncing from OpenBow to Kubernetes secrets where it's needed. I also have Cert Manager, obviously. Then in here, I have one namespace per environment, development, stage, production, staging for each project. I have 2 projects. One is called default and one is called Doclet. So each gets its own namespace. My Doclet project is only deployed inside the development namespace. So if I can actually query my pods inside that namespace, wrong one. So if I go get the namespace here and then query the development, I'm just going to check if I get the pods inside the development namespace of my Doclet application, I should be able to see that I have all my pods. I have the Colab, the document, the front end, I have my Nats, I have my Postgres, and then the admin panel. Now let's look at some of the pods that are actually running inside the control plane namespaces. So if I go inside the control plane, for example, I can do a kubectl get pods inside this control plane. And I have my Backstage component, I have the gateways, I have the K gateway for all the MCP stuff, and then I have this component called the Portal Assistant. So Portal Assistant is the actual component that shows the bubble interface inside the logs that I was chatting with earlier. Now, if we look inside the observability plane, I will go and look at the pods there. I will have a bunch of things going on there. I have Alert Manager, I have FluentBit for logs, I will have Prometheus somewhere here, and then I have OpenSearch for logs storage, and then I have this SRE agent. We're going to look at it in a second. All of these components are actually deployed by default and configured by default to give you all the observability logs and metrics that you need. So you don't need to do any extra work. However, sometimes we might actually need to customize them. And so typically what platform engineers or platform teams would do is that they will actually have to craft individual alerts per component per type of failure, which is good, but it can be cumbersome. That's where OpenChoreo created this concept of traits. A trait is basically a description of a high-level potential failure that will automatically be converted by the control plane into Prometheus Alert Manager alert. In this case, for my Doclet document, which is my backend, I have created a trait that detects when there is a connection refused in the log. So this would indicate actually that the backend have failed to connect to the database. And then what it will do is that it will trigger an alert. What this alert actually will do, coming from Alert Manager, so the error will be triggered to the logs, which will be stored in OpenSearch. Then it will be collected by the observer, which will forward it to my SRE agent, which is what we're going to look at next. Okay, so now we're actually ready to simulate a failure and see how the built-in SRE agent of OpenChoreo will do a full analysis of the entire system, and it will create what we call an RCA, a root cause analysis report. The built-in SRE agent is running inside the observability plane, and it's bound by the rule-based access controls that you have set up. So it can only access the things that you allow it to access, leveraging built-in Kubernetes RBAC for that. So it's not going to go rogue and start just randomly poking components if you don't allow it to do that. Let me show you. Because OpenChoreo is built on a GitOps practices, if I would to delete any of these components, it will be restituted very quickly. But what I can do is I can actually simulate in causing a failure, which would be a very common one, through scaling down my Postgres database. So let's do that directly into the console. So I'm going to go and scale down my stateful set through kubectl or kubecontrol. And now I should be able to see that I don't have a pod anymore running inside my development namespace. I only have the admin panel. Now I will trigger a logs watch on the SRE agents, and I can actually see that it's already probably doing something. And then meanwhile, I will go and cause this error to show up. So if I go to the front end and just reload it a couple of times, this should trigger alerts in my document backend to say that, okay, I cannot connect to the database, and I can already see it here. So if I refresh the logs one more time, I should be able to see, yeah, I already see the alert being triggered. I can actually look at it directly inside the Doclet document components. Looking at the logs, I can see, all right, there is an error. So let's just refresh a couple of more times just to make sure that we actually cause the error. Now, I can see that actually my SRE agents have already detected this error, and it's already started an analysis task. It will trigger a bunch of tools because it's using MCP servers. So it will actually query a bunch of tools, and it will talk to a large language model. In this case, it's using ChatGPT, but it can actually use multiple models as long as it's OpenAI compatible. And then if I go back to my interface and go to the catalog, to the Doclet application, to the RCA report, I should be able that there is actually an RCA report in progress. So if I give it a couple of seconds, I will be able to see the final root cause analysis report. And I can already see that my agents have already created it and finished. So if I click on the actions item, it gives me a few suggestions as a quick fix, which I could actually apply directly through the interface. This is, of course, again, subject to RBAC, to rule-based access control, but it also gives me like a full system timeline because it have queried all the logs. It have given me also the entire investigation path, so all the steps the agents have followed to investigate the errors. And then it will give me what are the likely root causes, what are the unlikely causes, and then what are the actionable next steps. And one of them is to say, well, ensure that there is a schema in the database is created before serving traffic, and then ensure that there is a release binding, which means that there is actually a way for the document database to talk to the database. Now, I'm not gonna follow any of these, because I know that my error is quite simple and it's quite straightforward. But imagine if this was actually a multi-component failure caused by multiple components going down at the same time, then you will have a full analysis that shows you everything across the logs of all the components that might be involved. So what I'm going to do is I'm going to stop my logs, just go back and scale my database back to 1. And then I can just look at the logs to see, oh, my database is back. And I know that for this particular application, the schema will not be created because the database is based on a temporary folder. So I will just have to restart the document, which will then create the schema automatically. And so now if I go back to my Doclet projects, if I refresh my front end, I should see that the error have disappeared. And in a few seconds, also the root cause analysis report will disappear, because the same way that it was created with the incident, when the incident happened, it will also be automatically deleted when the incident is not there anymore. And you can see this is actually pretty cool, because the SRE agent acts as a human. It actually investigated logs across multiple components. It looks at metrics. It looks at a lot of other things, and it created a full report of what could have caused the issue, giving you suggestions for what might be the fix. And may I add, it actually created a blameless report. It didn't point to a particular person to say, oh, this person caused the issue. It just said, hey, this component is down. You might want to look at this. And if I would have waited long enough, even actually my database would have been eventually reconciled, because it's based on GitOps. So OpenChoreo would detect drift and it will recreate the database automatically. I didn't wait. I scaled it back up and my application is working again. But eventually the system will just heal itself and it will reconcile automatically, because that's the power of reconciliation loops inside of Kubernetes. This is actually why I'm very excited about OpenChoreo. It combines developer-friendly front ends with very powerful backends with GitOps philosophy, and then built-in AI assistant tools for allowing you to actually debug and figure out how your system works, what's the relationship between the components, and then query using natural language what's going on inside your application. So if you're ready to stop maintaining glue code and you want to start with something that actually works out of the box that you can customize to your needs, I highly recommend you go look at OpenChoreo. They have a playground where you can actually get your hands on and try it for you, or you can just follow my step-by-step guide that you will find in the notes, where you can deploy the entire system into GKE. I will also link another video or tutorial from OpenChoreo where you can deploy OpenChoreo to any Kubernetes installation that you want. It's Kubernetes native, so you can deploy it anywhere. Don't forget, OpenChoreo is an open source project, part of the CNCF. So go give them a star on GitHub. If you have any questions, there is a Slack channel on the CNCF Slack that you can actually go look at and ask your questions. As always, I hope this video was useful. I hope that you will give it a try. Let me know if you comment when you do, and let me know what you are building next. And for me, I'm going to tell you goodbye. I'll see you in the next video. Cheers.